All right, so if I'm going to do this one, they're asking us to solve between the interval of 0 to 2 pi. So then we're just going to list out the ones that are real solutions. And if it ends up being that place at 0 or 2 pi, we're going to write it as 0 and not 2 pi, because this one, that's what the directions ask us to do for this one. So for this one, I don't really know how to solve it as is particularly. None of the strategies that I've talked about in the past seem to work for this one, so I'm going to try to get these to be like something I can work with here. So I'm going to change this one to 1 over sine x and this one to cosine x over sine x is equal to 1. And then I guess, what would I do from here? I guess I would multiply through by sine x. There's a couple ways we could go, but I'm just going to multiply both sides by sine x, and that puts us here. Now, once again, this really isn't one that I know how to solve because I need to either change sine to cosine or cosine to sine. The trouble is that we don't have an identity that does that. We only have an identity that does it if I square both sides. So if there's cosine and sine squared. So that's actually what I'm going to do. Now remember, if you square both sides, you're potentially making those extraneous solutions, which I talked about in the other videos. So if you're going to do that, you're going to have to make sure that you check at the end to make sure that you haven't created any extraneous solutions. Now from here, I know that I'm going to change the sine to cosine because once again, I don't know how to change this to a cosine, but this to a sine, but I know how to change this to a cosine. So that's what I'm going to do. I'm going to do cosine x plus cosine squared x is equal to 1 minus cosine squared x. And now I'm going to get everything on the same side because of course this is now just a quadratic equation, right? So the 1, when I subtract 1 from 1, I don't get anything. I have 2 cosine x, and then when I add this to this side, I get 2 cosine squared x. And this is a nice one because I don't even have to try to factor a trinomial, right? I just factor out the common factors. That'll be 1 plus cosine x. And now this is a lot like all the ones that we've talked about before. I have 2 factors that are set equal to 0. I'm going to use my zero product property, which says that, if 2 things are multiplied together that give you 0, well, one of them at least has to be 0. So I'm going to figure out what will make each of these 0. So of course this is cosine x is equal to 0, and this is cosine x is equal to -1. Well, these are both quadrantal, right? So either again, you can look at the picture of cosine and try to figure it out from there, or you can look at these points on our unit circle, and I think a lot of people choose this way, but sometimes it's actually easier to see it here. Like I can see this is the -1, that's at pi. That's at pi, and then these ones are, these ones are at 1s. If I had 1s, we would see, and these are the 0, so that's pi over 2 and 3 pi over 2. So again, some people always go to this, and some people always go to this, whichever one helps you more. So this one, since both of these have a period of pi, I know that really, like I'm looking at all the solutions between 0 and 2 pi. So I'm looking at this one and this one. So that one's pi over 2 and 3 pi over 2. And then I'm looking at this one, and that one is pi. The trouble is I do have to go back and make sure that those are not extraneous solutions. So I'm not going to circle them yet. I'm going to check them before I go ahead and make sure. And I'm actually going to look at them this way because sometimes this actually is a little bit easier to see if it's not going to work. And why do I have to check? Because if you take a look here, there's a couple things that I did that could cause a problem. This one definitely has a domain restriction, right? There's some values, whatever would make sine x 0. I eliminated that restriction in this one when I multiplied through by sine. So that's a place where I potentially made extraneous solutions. Then I squared them. So that's another place I potentially made extraneous solutions. So I'm going to go and check. So I have to think, does pi over 2 work here? So 1 over sine of pi over 2. Well, again, sine is this one. So, or you can again look at these, and you're just looking at the y the y values. So pi over 2 is this. That's going to be a 1, right? A 1 over 1. Plus cosine over sine, so we're looking for cosine of pi over 2 and sine of pi over 2. We already know that this one is a 1, and cosine of pi over 2 is a 0. So that's 1 plus 0 equals 1. That one works. So this one is good. Then we got to do the same thing with 3 pi over 2. Okay, so it's going to be, again, 1 over negative 1 plus negative 1 is equal to 1. Well, this is negative 1 plus 0 is equal to 1. That one does not work. Now let's try pi. So I have 1 over what's sine of pi? Well, sine of pi is 0, and I already see that that's not going to work because I can't have that at all. So the only one that actually works here is this one, between 0 and 2 pi. Okay?